DSA run shows the giant aneurysm. 3D image being rotating to study the neck of the aneurysm. There is a big lobule laterally involving the artery. There is another small aneurysm in the cavernous segment. 3D can tell us which angles to keep during the procedure. Static imaging showing the broad neck. Anterior view showing the large lateral lobule involving the parent vessel. From other angle, the involvement of the parent vessel. This view can tell us the exit of the distal vessel, so we know where to try to attempt the wire. The sizing can be done, as well as the calculations for the flow diverter placement. The wire taken across using those angles. Now the wire is overlapping the aneurysm. We don't know about the MC bifurcation. However, using biplane technology, in the other angle we can see the bifurcation, and that wire was taken into the larger lower division. Wire was taken very distally, then the microcatheter was threaded over it. The plan was to exchange. It wasn't possible. The catheter became unstable. Then wire was taken across the aneurysm. An attempt was taken to hook the distal vessel. We could hook it, but it wouldn't navigate further. So then the marksman was taken along the wall of the aneurysm, and it pointed inferiorly. This helped us to hook it, and the wire now was stable enough for us to take it distally into the middle cerebral artery. The wire was sent very distally. Only when the hard part of wire was in, we could navigate the marksman very distally. Attempt was made to straighten it. It wasn't possible. So we again took it distally, brought the wire into the marksman, and then straightened it. This is static imaging showing the steps. The wire tip at the loop of the catheter. You can see the arrow, and then with a torque it was pulled out, straightening the microcatheter. This helped us to avoid the exchange. After this, we decided to take in the flow diverter. Again, you can see slightly unstable microcatheter. With careful manipulation, we could take it ahead. Then we, using a coiling microcatheter, we coiled the aneurysm partially. The loop near the neck was in the lateral lobule, not in the parent vessel. The flow diverter was initially deployed in the middle cerebral artery, partially opened up, then dragged back into the ICA bifurcation very carefully, now being deployed. Subtle movements of microcatheter tip to help to open the flow diverter. It opened up well in the aneurysmal segment. Static imaging showing the distal guiding helps us to in this maneuver. Flow diverter being further delivered in the cavernous segment. After delivering, the microcatheter is pushed to open it up. The problem was distally, it didn't open up at that bend. We deployed it, and then we took microcatheter into it, as this video will show. The microcatheter was slowly navigated into the flow diverter, and then the tug of the wire opened it completely. The static imaging showing before the deployment, and then how after deployment it doesn't open up at the bend. Microcatheter now in it helps to start opening it, and then the wire tug given to open it at the bend. Now this image shows where it is not really well opposed to the wall. There is a small gap. So we took a balloon. The wire tip is very distal with a loop, so that doesn't injure. balloon inflation done. And now final image shows well open flow diverter. The 2D image shows well flowing artery, very minimal lack of opposition. The DSA shows well flowing artery with slowing of flow in the aneurysm. Arteries are all well filling. This is the VASO CT. You can study the flow diverter very well in all the curves. Thin section shows how the wires are opposed to the wall. The static image, and this is a thin section, the distal most flow diverter well opposed with a small gap in the cerebrospinal ICA along the cavernous bend, and the proximal flow diverter which is now very well opposed and completely open. And we can see in cross section the small gap where we have done the balloon angioplasty, and as well as very small gap left. This should not cause any problem. This is the XPER CT showing that there was no bleed during the procedure. In the upper cuts we can see some contrast staining.